how to calculate reactions. And this is a very important question and the most easy question in your exam. I do recommend to start with this question. But just a reminder, we are talking in this chapter or this module about different types of support. As I mentioned in Tuesday, we have 3 different types of support, and be careful. Please read your problem carefully. What type of support do you have? If you have fixed support, that means we have 3 reactions. One vertical as a force, one horizontal as a force, one moment as a reaction. If you have hinge support, sometimes I can call it pin support. Same meaning. That means we will have 2 reactions, one horizontal and one vertical. It's up to you. You can assume what you want. But I need horizontal and vertical. Sometimes you can assume your reaction like this. Horizontal and vertical. I don't care, up or down, left or right, but we need 2 reactions, one horizontal and one vertical. If you have roller support, that means I will have only one reaction, this way. Once you set up your reactions, we have 3 equilibrium equations. Summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0. I do repeat this information. Your moment equal force time distance. Your force and your distance directions must be perpendicular. I mean, if you have a force in a horizontal direction, your distance must be measured in the vertical direction. If your force in a vertical direction, your distance must be measured in a horizontal direction. Your force and your distance must be perpendicular. Keep in your mind, if you have a force and you have distance, both of them in the same direction, if you multiply both of them together, that's wrong. This is not a moment. This is not a moment. It's something else. It's a work, not a moment. Your force and your distance must have to be perpendicular. I can assume a clockwise rotation is my positive, or I can assume counterclockwise rotation is my positive. Once you assume one is positive, the opposite one will be negative. It's up to you. And I did one example last meeting, this one. I would like to highlight another point today, which is the distributed load. Because you will find this load or this type of load on the coming exam, distributed load. Sometimes I will give you a rigid body, looks like this. And I will give you a load, looks like this. This load is called distributed load. We learned before from the beginning of this semester that your load looks like this. Only one arrow at one specific point. This load is called concentrated load. Concentrated mean one arrow at one specific point. But sometimes I will give you a load which is distributed, not only at a specific point, but on a lens. So your lens looks like this, total lens L, and this distributed load has a value. This value represents this height. So W. It's very easy. I will convert this distributed load two equivalent concentrated load. I will convert this distributed load to this equivalent concentrated load. How? Very easy. The centroid of this rectangle, this distributed load is uniform, so represent a rectangle. This rectangle has a centroid here. At this centroid of the rectangle, which is at the mid distance, this distance will be L divided 2, and this distance will be L divided 2. I will put here equivalent, which is one concentrated load. This concentrated load will be W times L, which represented the area of this rectangle. The area of this rectangle is W, the height, times the length, L, you can get the value. For example, if I'm giving you distributed load, looks like this. This is your beam, or this is your rigid body. And this is your distributed load. This load is given 5 pounds per foot. And your distance here, this total distance is 10 feet. So how can I convert this distributed load to equivalent concentrated load? Here is your rigid body. Keep in your mind, the centroid of this rectangle at the midpoint here. So at this midpoint, I will put equivalent. How much? What is the area of this rectangle? The area of this rectangle equal 5 represents the height of this distributed load. And the total length equal 10 feet. If you multiply 5 by 10, it will give you 50 pounds. So I converted the given distributed load to equivalent concentrated load. That makes sense? Then I can work with this 50 pounds and I can forget the distributed load. Any question about how to work with the distributed load? I will do example right now. Let me work with this example. It's a frame. I don't care. I don't care what is the type of the rigid body. Frame, beam, truss, whatever. I don't care. My point is, what type of support do you have? The first, we have a roller at A. So at point A, we have a roller support. That means I will have vertical reaction here at A. I will call it YA. And we have pin support. Looks like I forget N. We have pin support at C. So this C will have two reactions. One like this, and maybe one like this. I don't know. You can assume your horizontal reaction like this. It's up to you. Both of them works. So XC and YC. Because it's a pinned support. We need to figure out the reactions. So I need to apply 3 equilibrium equations. Summation f of x equals 0. Summation f of y equals 0. Summation moment at any point equals 0. But before starting, I would like to highlight very important aspect that we have uniform distributed load. Can you see this rectangle? These arrows over AB, they are uniform distributed load. I cannot start until I convert this to equivalent. So the centroid of this rectangle at mid distance, which is 5 feet from this side, and 5 feet from the other side. How much will be this load? It will be looks like this. It will be 1.5 times 10. It will be 15 kib. Does that make sense? Once you converted your distributed load to equivalent, please forget the distributed load and work with the 15 kib, which is the equivalent load. Let's start. What forces do you have in this rigid body in X direction? X direction, which is horizontal. If you look, please don't forget any force in X direction. I have positive XC. I have negative 2. Anything else in X direction? Do you think we have any more forces in X direction? I don't think so. Equal 0. So in a minute, XC will equal 2. Will equal positive 2. What you mean by XC equal positive? I mean, you assumed the correct direction for XC. You assumed the correct direction for XC, which is to right. Summation f of y equals 0. So I have positive YA. I have negative 15 kib, which is the equivalent in the negative Y direction. I have positive YC. That's it. Nothing else in Y direction. This one, and this one. Nothing else in Y direction. I can simplify this equation. YA plus YC will equal 15. And this is an equation with 2 unknowns. I cannot do anything more. I will take moment at any point. You can select any point, A, B, C, D, any point. It's up to you. But I give you a hint. Last meeting, I do recommend to take moment about the point with the maximum or the highest number of reactions. I think I have point C with 2 reactions. So I will take moment at C. I will assume my counterclockwise is my positive direction. So anything else will be negative. Then I will set up my equation. I will multiply XC by distance. I will multiply YC by a distance. I will multiply 2 kib by a distance. I will multiply 15 kib by a distance. I will multiply YA by a distance. Equal 0. Hey, you have to list everything in on your body. XC, YC, 2 kib, 15 kib, and YA. Remember, as I mentioned at the beginning, once you converted the distributed load to equivalent, please forget the distributed load. We are working with the equivalent right now, which is 15, located at this point. Midpoint. So we are taking a moment at C. That means I am sitting at C. What is the distance between XC and C? 0. What is the distance between YC and C? 0. What is the distance between 2 kib and C? What is the distance between this point and this point? Any help? What is the distance between the 2 points? C, that you are taking a moment about, and the point where 2 kib is located. What is the distance? Any help?
Is it 6?
6. Make sure and ask yourself this question. 6 feet direction and the 2 kip direction are perpendicular or not? Yes or no? 6 feet in a vertical direction. This 6 feet in a vertical direction. And your 2 kip in a horizontal direction. Why no, Kylie? 6 feet as a direction is vertical dimension. And your 2 kip is a horizontal force. So the horizontal force and your vertical distance are perpendicular. Does that make sense? Okay. So we are good. If you found your force and your distance are perpendicular, we are good. Keep going. Keep going. The next one, 15. What is the distance between 15 and your point C? Keep in your mind, you're 15 in a vertical position. That means your distance will be measured in a horizontal direction. I think it will be 5. So what is the horizontal distance between 15 and the point C? The horizontal distance is 5 feet. This one. YA is located at point A. What is the distance between YA and the point C? Keep in your mind, YA is a vertical reaction. So your distance must be measured horizontally. So what is the horizontal distance between point A and the point C? Between YA and the point C, it's 10 feet. Make sure your force and your distance must be perpendicular. What is the horizontal distance or what is the vertical distance? Based on the direction of your force. For example, 2 kip is a horizontal force, so what is the vertical distance? 15 kip is a vertical force, so what is the horizontal distance? YA is a vertical force, so what is the horizontal distance? Does that make sense? So please pay attention to make sure your force and your distance are perpendicular. I don't care about this term, so I don't care about the sign, positive or negative. I don't care about this one, positive or negative. 2 times 6. This 2 is moving to left. If this force would like to rotate about C, I think it will rotate counterclockwise, so it will be positive. This 15 times 5, if this force would like to move and rotate, it will move and rotate counterclockwise. It will move down and rotate counterclockwise. It will be positive. This YA is moving up. This YA is moving up. If this force would like to move and rotate, it will move and rotate this way, which is clockwise. It will be negative. The only unknown in this equation is YA, so I can figure out the value of YA using my calculator. 2 times 6 plus 5 times 15 divide 10, I got positive 8.7. I will go back here and put YA equal 8.7. I will find YC. It will be 6.3. So I found the reactions for this frame or this rigid body, XC, YC, and YA. Looks good. I will do one more example. And I will have a question. If you answer this question, I will give you extra 3 points. Okay? Let's do this example. Example number 2, I think. 3. Example number 3. We are given a rigid body which is fixed at A. At this support, at A, we have fixed support, nothing else. Only one support at the point A, which is fixed. If you go back to this slide, if you have fixed support, that means we have three reactions. Vertical reaction as a force, horizontal reaction as a force, and the moment. So, since we have fixed at A, I will have horizontal reaction, vertical reaction, and moment. The vertical reaction will be called YA. The horizontal reaction will be called XA. The moment will be called MA. Nothing else. If you have fixed support, we will have three reactions. One more time, I can highlight it here. If you have fixed support, like this, or like this. Fixed support means we have three reactions, one vertical, one horizontal, and one moment. One vertical, one horizontal, and one moment. This is how to put your reactions if you have fixed support.
Why is the moment down on these examples instead of up?
You can assume what you want. If you don't like my directions, go ahead and put these directions like this, and like this. That makes sense? You can assume any direction, but please, at this point, put three reactions. One vertical, up or down, up to you. One horizontal, left to right, it's up to you. A moment, clockwise, counterclockwise, it's up to you. The direction is up to you, but I need vertical, horizontal, and a moment. Does that make sense?
It does, but the vertical and the horizontal reactions make sense to me, but why does the moment go opposite? Like if this were an arm hanging off a building, wouldn't the end of the arm want to rotate down, which would make the moment up?
It's a good question. I will not pay more attention about what is the correct direction. Assume what you want, and then your calculation will help you to figure out the correct direction. Does that make sense? So I can show you what everything looks like. Keep in your mind, if you are holding piece of wood in your hand, you are holding this piece from this side, and you imagine that there is a load on the end of this piece, a pencil or a piece of wood or a piece of metal or anything. You are holding it from this side, and we have a load at the tip of this piece. This force would like to rotate this piece down. This is called action, because this action is coming from the applied force. Your hand, which is holding this piece, will react by a reaction. That makes sense? So we have a force would like to apply action, and we have support, which is your hand, will react by something called a reaction. Your reaction must be opposite to the action. So I don't like to pay more attention about reaction, action, where is the correct direction. Go ahead and assume what you want, and then we will have final answer. If your final answer is positive, you assumed the correct direction. If your final answer is negative, that means your value is correct, but in opposite direction. Does that make sense?
Yes, it does.
So I will assume any directions, but keep in your mind, we must put 3 reactions, one vertical, one horizontal, and one moment. Then let's start. Before starting and before applying the 3 equilibrium equations, summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0, we have uniform distributed load. Looks like a rectangle. We need to convert this distributed load to equivalent. Then we can forget it. So this rectangle will have a centroid at the midpoint. Midpoint of what? Of 2 meters. Be careful. So this distance will be 1 meter. And this distance will be 1 meter. And your distributed load will be equivalent at this point. How much? 10 times 2. 10 kilonewton per meter. This is the height. Time 2, this is the total length. So 10 times 2 equal 20. So we have here 20 kilonewton. That makes sense? Then I can forget the distributed load. So what we have so far, 20 kilonewton and 10 kilonewton, and we have reactions. Let's start to apply the equilibrium equations. Summation f of x looks like, for me, I have only negative xa, which is in the negative direction. This direction is negative. That's fine. Do you have any more forces in x direction? No. So xa will be 0. Summation f of y equals 0. Looks good. We have negative 10, which is this one. We have negative 20, which is the equivalent force. And we have positive YA. These are the only forces in Y direction, equals 0. I can find YA. YA will equal 30. Guys, are you still here? I'm sorry, looks like there is error in my internet connection. So can you hear me and can you see my screen right now?
Yes, we can.
Okay. So summation f of y equals 0. We have negative 10, we have negative 20, and we have positive YA. So I can find YA will equal 30. So I am done with XA, I am done with YA. The third equilibrium equation, I will take moment at any point. You can select any point, but I will select point A with the maximum number of reactions. And I will assume my counterclockwise is my positive. You can assume what you want. So any rotation counterclockwise will be positive. Any rotation clockwise will be negative. Then I will list everything. MA time, XA time, YA time, 20 kilonewton time, 10 kilonewton time equals 0. I listed everything. And I have question, and you need to answer it one by one. The first question, what is the distance between XA and point A? What is the distance between XA and point A? Any help?
0.
Thank you. But this is not the question of the extra point. What is the distance between YA and the point A. YA and the point A will be 0 also. What is the distance between 20 kilonewton, which is located here, and the point A? Your distance will be 1 meter. And make sure 20 kilonewton in a vertical direction and your 1 meter in a horizontal direction. They are perpendicular. Looks good. What is the horizontal distance between 10 kilonewton at this end and your point A? What is the horizontal distance? How much? How much?
3.
3. Perfect. So far, so good. And your distance is perpendicular to your force. I need some of you or one of you. This is a question with the extra credit. What is the distance between MA and your point A? What should I put here? At point A, we have 3 reactions: XA, YA, MA. XA multiplied by 0 because we don't have distance for XA. YA is multiplied by 0 because we don't have distance for YA. MA will be multiplied by what? 0? Or we have distance?
3.
3. Any other answer?
Would it be 1.5?
1.5. Any other question? Any other answer? Okay. Actually, I don't need to multiply MA with any. Why? Keep in your mind, if you have a force, this force will need distance to create a moment. If you are given a moment, does not need distance to be a moment, because it's already given as a moment. So keep in your mind, this reaction is a force. This reaction is a force. This force is a given force or equivalent force. This 10 is a given force. All of them are forces. They still need distance to be converted to a moment. But MA is a moment as a reaction. It's already moment. That means it does not need distance. We don't need distance. It's a mistake if you multiply MA by any, because MA is already moment. Does not need distance. That makes sense? That makes sense?
Yep.
So if you are given already a moment, like this reaction MA, we don't need distance. Don't multiply it with a distance. Then I can figure out which one is positive and which one is negative. This one, I don't care. This one, I don't care. For MA, in this direction that I assumed is clockwise, unfortunately, it will be negative. 20 times 1 will be positive. 10 times 3 will be positive. The only unknown in this equation will be MA. It will be, I think, 50. Positive 50. Positive means the direction of this MA is correct, counterclockwise. I'm sorry, clockwise. Let me do another example which have moment to see how this moment will be done. I will open another, this one. I will solve the last problem of practice exam 2021, this one. I will solve it for you. So we have beam, I don't care, and we are looking to calculate reactions. A is hinge. So I will have two reactions at A, YA, XA. B is a roller. A roller support means we have only one reaction, YB. So before applying summation f of x equals 0, summation f of y equals 0, summation moment at any point equals 0, we have a little correction or a little modifications. The first one, we are given equivalent, distributed load, looks like a rectangle. So I will convert it to equivalent at this point. 40 times 8 will give you a value. 40 times 8 will be 320 kilonewton. That makes sense? 40, this is the height, which is given. 8, which is the total length. So if you multiply 40 by 8, you can get the area of this rectangle, which is 320, which is the equivalent for your distributed load. And keep in your mind, this distance will be 4 meters, and this distance will be 4 meters, because the total is 8. This 20 kilonewton is inclined, not in X, not on Y. So I have to convert it to two components, one horizontal and one vertical. Go back to module number 1. The horizontal component is, if you assume this angle is theta, so it will be cosine. Cosine this angle will be 3/5. So this one will be 12. And this one will be 16. So I converted the inclined force to two components. And keep in your mind, we are given at this point also, given concentrated moment here equal 150 kilonewton meter. Can you see this given arrow? We are given an arrow here. This is the vertical component 16, and we are given arrow here as a moment. So don't forget this. We are ready. I am ready right now. I converted the distributed load to equivalent. I break the force to two components. We are ready. Summation f of x equals 0. That means we have positive xa. We have positive 12. This horizontal component, 12, is positive in x direction, equals 0. That means your xa will be negative 12. Negative means I assumed the wrong direction for xa. It should be to left, not to right. It's not a big deal, but just let me know what is the correct direction. Summation f of y equals 0. I have positive ya. I have negative 320. I have positive yb. I have negative 16. Ya 320, yb, and the vertical component 16 equals 0. I can simplify this equation. Ya plus yb will equal 336. Then I can apply moment. At any point, I will select A, because A has the maximum number of reactions. And I'm going to assume this clockwise rotation is my positive. So XA will be multiplied by YA multiplied by 320 multiplied by YB multiplied by horizontal component 12 multiplied by vertical component 16 multiplied by, and we are given a moment 150 multiplied by equal 0. Everything must be listed. Let's start. My question is, what is the distance between, I'm sitting at A. A is my point. What is the distance between XA and A? 0. What is the distance between YA and A? 0. What is the distance between 320 and A? 320 and A? 4. And your 4 and your 320 are perpendicular. We are good. What is the distance between YB and A? It will be 8. And both of them are perpendicular. One more question. What is the distance between the horizontal component 12 at this point and the point A? Anybody can tell me what is the distance between the 2 points? What should I write here? Any help? Any help? What is the distance for 12? Thank you. Yes, it's 0. Why? This distance is 0. And the 16 at the same point will be multiplied by 11. You are kidding. Why? We are talking about the same point. We have a point here, have 16 vertical component, and they have 12 horizontal component. And we have point A is located here. And this distance is 11. That's correct. 8 plus 3, 11. I cannot multiply this 12 by this 11. Do you know why? Because the 12 force in the same direction for the 11 meter. Both of them are horizontal. I cannot. Your force and your distance must be perpendicular. This is the reason why for 16, which is in a vertical direction, is multiplied by 11. So what about 12? 12 must be multiplied by vertical distance. Do you have a vertical distance between this point and this point? No, we don't have vertical distance between the 2 points because both of them at the same level. So this is the reason why 12 is multiplied by 0. One more question. 150. 150. We have at the same point here 150. Anybody can tell me this 150 at this point will be multiplied by what to take moment at A? What is the distance required for 150? This is another question. At the same point, we have a moment given 150 clockwise. This moment must be taken in this equation. So what is the distance needed for 150 between this point and this point? Any help?
None.
What you said? What you mean by no or none?
Because the 150 is the moment.
Thank you. We don't need distance. So this is wrong if you write something here. Don't write anything. Just put 150 as it is. Because 150 is a moment. Does not need distance. We don't need distance. Don't tell me any number. 0, 1, 4, 3. No. 150 is a moment. Then I can figure out the direction. Clockwise rotation is my positive. I don't care about this one or this one. 320 will be positive. YB will be negative. I don't care about this one. 16 will be positive and 150 is positive. The only unknown in this equation is YB. I can figure out the value of YB. Then I can put here YB to figure out the value of YB. YB will be 320 times 4 plus 16 times 11 plus 150 divide 8. It's 200.75. If you put here 200.75 minus 336, it will give you YA 135.25.